We're going to look at free fall. Specifically, we're going to look at velocity versus time graph for a ball that is tossed up in the air. And we're going to draw the velocity versus time graph looks like this. And let's just talk about what that equation looks like. Let's assume we know that the relationship between acceleration and velocity is acceleration is change in velocity over time, which gives me v final minus v0 divided by t, and I can rewrite that as the velocity as a function of time is equal to v0 plus at. Now in our case we know that the acceleration is minus 10 meters per second squared, and so I have a line which has a negative slope. So the slope of this guy is minus 10 meters per second squared. And let's assume that my initial velocity is 15 meters per second. So that says at this point right here is 15 meters per second, and if you solve that, plug it in, solve this equation for v equals 0 or v final equals 0, then it's pretty straightforward to see that the time for that is 1.5 seconds. And again, the idea being that every second it loses 10 meters per second of velocity, and so that forces, or this makes this point right here be 1.5 seconds. If we look at, remember we said that the displacement is the area underneath that curve. So the area, this area kind of right here, and that area looks like 1/2 the base, and the base is 1.5 seconds, times the height, and the height is 15 meters per second. And if I go through and do that out, I come up with a height or a displacement of, or an area of 11.25, and the seconds cancel out, leaving me meters. That's also consistent with the displacement is equal to the average velocity multiplied by time. The average velocity is, well, it's 15 meters per second plus 0 meters per second divided by 2, which is 7.5 meters per second. And what that gives me is a displacement that is equal to 7.5 meters per second multiplied by 1.5 seconds, which is 11.25 meters. You'll remember in class that we actually also derived a formula that looked like delta D is equal to 1/2 a t squared plus v0 times t, and if I plug the numbers I have into here, I end up with 1/2 minus 10 meters per second squared times t squared, 1.5 seconds quantity squared plus 15 meters per second times 1.5 seconds. And if I multiply this all out, this first term gives me minus 11.25 meters, and the second term gives me 22.5 meters, and again I get 11.25 meters. So we've shown that there are kind of multiple ways of getting the displacement, We can use area underneath the curve. We can use, which gave me 11.25. We can look at the average velocity and get 11.25, or we can use that the formula that we've used, the kinematic formula right here, and that gives us 11.25. Enjoy.